Hi everyone. Today the topic for discussion is STERN GERLACH experiment. This is an experiment which confines the space quantization in quantum mechanics. So, as an introduction, let me say that the spin is quantized. As we have discussed about the hydrogen atom in the previous classes, solution to hydrogen atom problem gave three quantum numbers. They are principal quantum number, angular quantum number, and orbital quantum number. But it doesn't explain about the spin quantum number. For electrons and other fermions, we can take up two values for the spin, that is spin up and spin down, and thus this experiment proves the space quantization predicted in quantum mechanics. And here we can see a diagram which shows the two possibilities for the z components of angular momentum, that is plus half h cut for spin up and minus half h cut for spin down, and this root 3 by 2 h cut gives the resultant value. And this diagram also shows that the quantization happens in the z direction. Now let us move to the experiment. STERN GERLACH experiment. In 1922, Otto Stern and Walter Gerlach experimentally demonstrated the existence of space quantization. They directed a beam of neutral silver atoms from an oven through a set of collimating slits into an inhomogeneous magnetic field. A photographic plate recorded the shape of the beam after it had passed through the field. And on the photographic plate, two distinct lines are seen, and it is due to the space quantization. So let us look at the experimental setup. They considered a simple setup. Here we can see an oven and it contains silver atoms. These silver atoms are emitted in all directions. They are further sent through the collimator, so this atom can pass through this. And now there are two poles of magnets, south pole and north pole. It is specially designed magnet where one of them is flat, that is south pole is flat and the north pole has a sharp edge. From here they get deflected or deviated like this, and finally they falls on the screen. So basically the silver atoms coming out of the collimator undergoes a deflection here because of the inhomogeneous magnetic field existing in this region. In normal state, the entire magnetic moment of silver atom is due to spin of only one of its electron. In an uniform magnetic field, dipole would experience a torque tending to align it with the field. In an inhomogeneous field, pole of the dipole is subjected a force of different magnitude. Due to this resultant force on the dipole, it varies with its orientation relative to the field. So let us conclude the experiment by looking into the classical and quantum approach on this experiment. First, classical approach. Classically, all orientations should be present in a beam of atom. The result would be merely be a broad trace on a photographic plate instead of a thin line formed without any magnetic field. So next is the quantum approach or the result of this experiment. The initial beam in this experiment split into two distinct parts. This is due to the opposite spin orientation in the magnetic field permitted by the space quantization. So that's all about the experiment. Thank you.